So today we're dealing with adding and subtracting for algebraic fractions. We have a rule here. We can add and subtract algebraic fractions by first converting the fractions to have a common denominator. From there, you then deal with like terms. That's when you can work it together. So we have a number of examples here that will start us through. I'm going to work through each example so that you know how to do it. So question one that I have on the board, and you might like to be taking this down in your book so you've got the notes. Yes. 7m over 10 minus 3m over 10. Now our principle is we have to have a common denominator. And here in this question, we already have it. So that means, just like a normal fraction, we can deal with our numerator, or the top. 7m minus 3m. They are like terms with just the m. So therefore, we end up with 4m over 10. That is all the working you would need to do for that question. Question 2, a little bit more tricky. K over 3 plus k over 2. We look straight away and we see that our denominator is not the same. They're 3 and they're 2. So we have to get that the same first. And the way we do that is we find a number that both numbers go into. In this case, 3 and 2, you can just multiply them together and you get 6. So I find it helpful to write next to it in a different colour what I'm multiplying by, and then I have my next bit of working. If I'm going to have 6 as my base, so I put 6 down as my base on both. K times 2 becomes 2k. K times 3 becomes 3k. And so then I can do 2k plus 3k, which gives me 5k over 6. For question 3, we have 5m over 6 minus 2m over 3. Again, I notice my denominator is different. I need to have a common denominator. But the second thing I notice, like some of our examples earlier, is that actually 3 will go into 6. So I don't just do 3 times 2, I can actually leave this one alone. Because in effect, it will stay over 6. And all I need to do is multiply this one by 2. So then, I have my common denominator of 6. There's a negative sign in the middle, make sure you keep that. I then have 5m for the first one. 2m times 2, multiplying algebraic terms. 2 times 2 gives me 4m. The sign goes with the term. So therefore 5m minus 4m gives me just 1m over 6. We don't need the 1 because that obviously means it is just 1m. Last example, question 4 for today, is 3 over 4 plus 7a over 10. Now the denominator here, 4 doesn't go into 10, so I can't use 10. I could do 4 times 10 and get 40. That makes my numbers much bigger and much harder to deal with. Or I could work out that both 4 and 10 go into 20. So then I think about it and I go, right, 4 goes into 20 5 times. So I multiply the top and bottom by 5. 10 goes into 20 2 times. So I multiply both by 2. My common base will be 20 plus something over 20. 3 times 5 is 15. 7a times 2 is 14a. I now add these together, but I notice straight away 15 and 14a are not like terms. I can't just join them together. I have to keep them separate. So actually, as far as I can go in this question, is to write it like that. 15 plus 14a, they must stay as unlike terms, but I can put it like that, all divided by 20.